Okay, it was the rational function. It was number 60 on, I think, page 434.
Let's take a look. I have everything ready here. Where are you guys? Okay. Yes. Would you tell me again? We said 464?
It was on page 434, and it was
434.
number 60.
Okay. So let's take a look at number 60. Is it this one here?
Yes, ma'am.
Perfect. Okay, so let's take a look at 60. So we have the integral from, so this is problem 60 on page 434. And this is the integral from 0 to 2 from 3x squared dx over 1 plus x to the third to the fifth power. Good. So it's a definite integral. We have to make sure that this function is continuous on this interval. But this function is not continuous or does not exist only when x is -1. So that's good. So now, as we discussed, we have to deal with this piece only because every time we have more than one term in the denominator is difficult to handle. So we have 1 plus x to the third, and then we have dy, which is 3x squared dx. So now we see that at the top we have exactly what we needed. So this whole thing is nothing else but dy, and this whole thing is y to the fifth. We do not go backwards when calculating definite integrals. So this will be the integral from y to -5 dy. But now we need new limits of integration. The limits of integration 0 to 2 are for x. They're not for y. So when I plug in 0 here to get the lower limit, I have 1. When I plug in 2 here to get the upper limit, I have 8 plus 1, which is 9. So therefore, we have y to -4 over -4 from 1 to 9. So basically, we have -1/4, and this is 1 over y to the fourth from 1 to 9. So it's 1/4. Now I plug in 9, 1 over 9 to the fourth, and then I plug in 1 minus 1. And of course, with minus in front. So now if you distribute at least the -1, so, or not, plus 1. Or just leave it as is. This is okay, this is okay. Is this clear?
I think the only thing that I got confused on was I forgot to change the forgot to change it from 2 and 0 to 9 and 1. That's just
you
what I messed
cannot
up
copy
at.
the
So
limits
thank
of
you.
integration. Yes, we cannot. It's very rare when they are the same, but most of the time they would not be the same, and I cannot copy them. Because those limits of integration are for x, I cannot copy them in a new integral that is in y. Good. Anything else?
Can we do 48?
Of
Unless
course.
you've already done that one.
Of course. No, we didn't. This was the first problem. This was the absolute first problem. Okay. I'm just putting attendance because if I forget, then I get screamed at the next day. So I put in the attendance in case you were wondering what I was doing. Okay, yes, Will, I'm sorry. Which problem we were working on now?
48.
From the same page?
Yeah.
Okay, 48. So let's take a look at 48. This is the integral from 0 to 1 from x squared plus 1 to the fifth dx. So the same idea. Anything that has more than 2 terms is more complicated to work with. So I'm going to say y equals x squared plus 1, and I need dy, which is 2x dx. I have the x and I have the dx, but what I don't have is the 2. We can always make up a constant. Only a constant Don't try to make up something else. That's not possible. So a constant is not a big deal. Multiplying and dividing by 2 did not ever affect anything. Okay, so then I have a 1/2 in front, and this is the integral from 2x dx, and then y to the 5th. So y to the 5th dy. But now I have to stop because I cannot copy the limits of integration for x to an integral in y. So when the lower limit is 0, I get y to be 0. When the upper limit is 1 for x, then I get 1 plus 1, which is 2. So then I have 1/2 y to the 6th over 6th from 0 to 2. Luckily, this is a polynomial. I only need to plug in 2, because when I plug in 0, I get 0. Sorry. So, one more time. When I plug in 0, I get 0 plus 1, which is 1. When I plug in 1, 1 squared plus 1 is 2. Sorry about that. So, when I plug in 2, I get y to the 6th minus when I plug in 1. Oh! So 2 to the 6th is 64 minus 1 is 63. So this is 63 over 12, and I simplify by 3 to get a 21 over 4. Any questions on any of the steps? Don't be shy, please. Ask anything.
Where'd you get the 1/2 from? Up at like the top?
So when I determine dy, I get 2x dx. I don't have the 2. I have the x, I have the dx, but I don't have the 2. So I multiply by 2 and divide by 2. Multiplication by 2 and division by 2 is 1. So 1/2 times 2 is 1. But I need the 2. The 2 is mandatory. I need 2x dx. It will always help if you redo the problems we do in class first, because I always choose similar problems. So that will help. Other questions here? Is this okay? Is there
I
any?
think there was like 62 that had a square root in it.
Oh, yeah. Always remember, I will also post the solutions. Posting the solutions will not replace ever the questions in class, just in case. Okay, 62 on the same page, 434. And this is the integral from 0 to the square root of 7 from 7x, the cube root of 1 plus x squared dx. The same procedure, the same idea. The problem is the fact that the cube root has 2 terms underneath. That is the problem. So let y be 1 plus x squared. So we need dy, which is 2x dx. Again, the same situation I'm running into. I need a 2, so I'm going to multiply by 2 and divide by 2. You cannot create an x and divide by x or x squared. No. Just a plain constant, a coefficient. That's it. That's the only one that you can make up. A number. So now, what do we have here? We have the 2 and the x and the dx. All 3 are in dy. 1/2 stays outside. There is a 7, so I'm going to move the 7 outside as well. And then 2x and dx will be dy. And this is the cube root of y, but I need it written as y to 1/3. Oh, I'm sorry. Do you want me to repeat from the beginning? I'm sorry. I forgot to stop sharing. So the quantity underneath a root, if it's 2 or more terms, that's a problem, because I can't simplify that. So I took y and I said, okay, 1 plus x squared is y. Therefore, dy, the differential, is 2x dx. I have the x and I have the x, but I don't have the 2. So multiply by 2 and divide by 2. So now these three are here. 7 goes outside. And the cube root is basically y to 1/3. Now we need new limits of integration. I cannot copy 0 to the square root of 7 that belong to x to y. I cannot. So when x is 0, y is 1. And when x is the square root of 7, this is 7 plus 1, which is 8. Is this okay? Any questions before we continue? Okay, so then we have a 7/2 in front. And then we have y to 1/3 plus 1, which is 4/3, over 4/3, of course, from 1 to 8. First I have to flip. I get 21 over 8. And then I plug in 8, but the cube root of 8 is 2. 2 to the 4th is 16, minus. The cube root of 1 is 1. 1 to the 4th is 1. So this is 21 times 15 divided by 8. Any questions so far? Any questions? Okay, 21 times 15, I got 315 divided by 8. And you know that you have the calculator and you can always verify the definite integrals, of course. So if you want to verify or you're not sure, you will always have to plug it in, but you have to determine this, right? Because this is exact. So you go to math and number 9, and you plug it in. Be careful how you plug it in, from 0 to the square root of 7. Okay, and then we have 7x, and then the cube root. I prefer 1 plus x squared to power 1/3, but that's me. You have other ways, of course. And then dx. So when I click enter, I have to get 315 over 8. 315 divided by 8. Any questions? Good, very good questions. Thank you. Anything else? Is there anything else that you would like to go back to? Any
Can you show that on the calculator again, how you check that?
Sure. Oh, which part?
Just how you plugged in the formula.
So you go to math and select 9, and then you have to enter exactly what you were given. So math and select 9. And then you have to enter the 0, the square root of 7, and then in parentheses 7x times 1 plus x squared to 1/3. Are there other questions? Anything else? Now, some calculators don't have this. I don't know what type of calculator everyone has. If your calculator doesn't have this feature, you can ask the proctor at the testing center to lend your calculator for the duration of the test. They are very well equipped over there. Okay, is there anything else that you wanted to go back to? Are there other questions? Okay, can we then continue with chapter 5? Yes, chapter 5. Not everyone made progress in Pearson. If you do not finish them by next Monday, you're going to fall behind. Some of you I saw, they finished, everything is perfect, but not everyone is keeping up. So please, so you can ask questions. Is there anything else before we continue with chapter 5? I mean, I will start from scratch, chapter 5. Okay? So let's continue. So as I mentioned last time, chapter 5 is perfectly connected to chapter 4 because it's applications of what we just studied, right? So chapter 5, applications of integration. And we're going to look at 2. One is consumer and producer surplus. And number 2, so this is section 5.1, and this is the second one is section 5.7. We only cover 2 sections in chapter 5. Differential equations, very simple basic differential equations. However, this section I think is the most involved section in the entire course. That's just my opinion. Okay, so let's go back to consumer producer surplus. And last time we looked at a demand function. Always remember this is number of units. Anything, but it can be X, number of units. And this is price per unit, P, price per unit. So let's say we have a demand function, and let's say we have a supply function. And we discussed this a long time ago in algebra. This is just algebra right now. The equilibrium point, where the demand and the supply are equal. Everybody is happy. We are happy to purchase. We are happy to purchase A units at the price B per unit. And the producers are happy. So they're supplying and they're happy, meaning to sell to us A number of units at the price B per unit. So what happens here is if I buy 2 pencils at the price of $3 per pencil, I have 2 times 3, and this is what I pay. This is what I pay. This area is what I pay. 2 something at the price of 3, 15 something at the price of 2 per unit, or whatever it is. When I multiply this by this, I get the exact cost for me for the whole thing. So when we do purchase, let's say 2 pencils at the price of 3 per unit, we do get this area on top of the rectangle, which is the value added. We're not getting money per se. We're just getting an extra, something called consumer surplus, a utility. Maybe we are happy, maybe whatever. We get this surplus. So this piece is the consumer surplus. We are paying 3 times 2, $15, but we are getting some extra at the equilibrium point. And the same thing at any point. So let's say you're asking me, calculate the consumer surplus right here. As you know, notice I haven't even graphed the supply function. Fine. And I will say at the price of A, at the number of units A, at the price B per unit, and I will tell you, you will end up paying this area. This is what you pay. And this is the extra you enjoy. This is your extra. You're enjoying extra, and you're not paying for it. This piece is the consumer surplus at this point. It doesn't have to be the equilibrium point. It can be any point. And we're going to look at problems in a minute. Okay, how do I calculate this? Because I'm asked to find the consumer surplus and then the producer surplus. For now, the consumer surplus. How do I find it? So here's how we find it. We will determine the total area because we know how, and we will subtract the area of the rectangle. Can anyone refresh our memory on how do we determine, so this is connected to the demand function. So how do we determine the area under a graph between 0 and A? Or here, how do I determine this whole area from which I will subtract this area to determine the consumer surplus? Regardless of, yes?
Would you make the bounds of the integral 0 to A?
The integral from 0 to A from the demand function d of x dx minus, because I don't want the whole area. This integral is the whole area. But this is not the consumer surplus. The consumer surplus is just the value on top of it. So minus
B times A.
exactly. A times B, which is the area of the rectangle. This is it. Let's look at the problem. Let's see how we determine the consumer surplus, CS, consumer surplus. And then we're going to come back and we are going to determine the producer surplus. So, here it is. Let's first choose, so here, let's read the problems, the requirements. D of x is the price, of course, in dollars per unit, yes, that consumer will pay for x units of an item, and S of x, of course, is the price in dollars per unit that producers will accept for x units. Find the equilibrium point. Find the consumer surplus at the equilibrium point, and the consumer and the producer surplus at the equilibrium point, which we'll do later. So let's choose a demand and a supply. In this case, let's find the equilibrium point and determine the consumer surplus first. And then we'll come back, we'll explain how to find the producer surplus, and then we'll go back to the same problem.